You're welcome to this live streaming on Understand Networking Concept for Cybersecurity. So, yeah, so I was explaining what an IP address is earlier, and then I made mention of each of the four octets comprising of what is known as 8 bits. Now, how do we calculate or how do we derive at these IP addresses, individually? Now, how this comes about is with the use of the conversion of binary numbers into decimal numbers. Now, how is this done? Like I said, in each octet we have 8 bits, and of course, certain bits were turned on for us to arrive at 72. Yeah, certain bits were turned on and off for us to arrive at 172. So in a case where we have every of the bits turned on in an octet, we will be having what is known as, or the number as 255 if every bit were turned on. So right here we have 0 0 0 0 0 0 0 0. So this is the 8 bits that you see here, and of course here they are all turned off. But in the event that every of them were turned on, you would be having the sum of 225 as the number here. Of course, now you understand what makes this place as well 172. Definitely certain bits were turned on and off. Year 223, year 09. Now, so that's how we arrived at at these. So now you understand the 8 bits concept here, which is written here. And then also it's important to know that the 4 octet comprises of a 32 bits. 32 bits. Yeah. So, and of course 32 bits is equals to what? Is equals to 4 bytes. So we have this address here that is reserved for the loop, what is known as a loop back, of course, which is also used in testing and pinging, and of course for troubleshooting. So right now I hope I've been able to help you understand these IP addresses. Now I know we can all see this, we can see here device, we can see here ISP, we can see here state, country. What does this mean? Simply what it means is, when you look at an IP address, how you're able to understand, okay, what address is, of course, given to my own device. Definitely it will be on the last octet. So your device will hold the last octet beats, and of course before second to the last, of course, is the beats from your ISP, which is your internet service provider. For now, don't worry how these addresses are designated. Just understand what comprises of an IP address is. So we are going to be taking it step step. And then of course we have the state, and then finally the country. So now for the purpose of a cybersecurity professional who is trying to troubleshoot or investigate um, 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 a certain intrusion, or it could be maybe a log file, as you can see here. Now what role do you think that this IP address is going to play? Of course, it will help the device, or it will help the professional to know what was the IP address of the intruder, as the case may be, or that device. It might not necessarily, it might just be a troubleshooting to understand what's happened. Now that could be done by accessing the log files and all, but of course it will help you to identify the IP address when you capture the packet, and of course that will give you other details, like the time, what happened during the packets, the to and fro of the network. But it's always important for us to understand what an IP address is and the duty that it performs. So let's move. So now we have what is known as the IPv4 address, and then we have the IPv6 address. It's very important to note these things. Now, this is the format for IPv4, which is something that we see Internet Protocol version 4, and then the Internet Protocol version 6. Now, this has or comprises of what is known as hexadecimals, together with it, and as against the IPv4, which we saw is a 32-bit number here, the IPv6, which is the version 6, is a 128-bit number, which is an advancement. Of course, we thought, during the IP version 4 that we might not be able to exhaust, the amount of addresses that, of course, will be available. But, that almost kind of seemed like something that would, be feasible, that humans could actually, exhaust the IP address that version 4 gives to us. Why? Because we can now see the innovations, the emerging of new technologies, and these technologies don't share the same IP addresses once, they are connected to the internet. So now, you know, technologies that had to come up with a new version of IP version 6, which of course surpasses the IP version 4, you know, um, um, will I say availability. Now, for instance, you can see the 4.7 billion. We are how many of us are in the world? But of course, you can see this now. But for the IP version 6, you can see it's over, you know, I mean, close to half a trillion, which of course, it's super modern enough. But currently, we have devices that run IPv4 and IPv6. So if you check your system, of course, you can see your system also has an IP version 6 IP addresses, but it's always important to know the difference, between these two addresses at first glance, at first sight. Now we have different types of IP addresses. We've looked at an IP addresses or an IP address. Now, what are the different type of IP address that we can have? We have public IP addresses, we have the private, we have the static, we also have the dynamic. Now, let's differentiate between these types of IP addresses. But of course, I know just from the glance of these, you can already have a picture of what this would mean. Yeah. Well, yeah. Let's take a deeper understanding on them. Now, the public IP address, of a system is the addresses that is used, or the address that is used to communicate outside the network. So when you have, for instance, your device, your phone has a private IP address, but of course, once it wants to communicate with the internet, it doesn't use that private IP address, it uses the public IP address. Now, this is what this means, that the public address of that your system or your device is the IP address that is used to communicate outside the network. Now, a public address is basically assigned by the internet service provider. You can see that clearly written here. Now, of course, which on the on our previous slide we saw, you can see by, so this portion of the IP address, of course, will be issued by your ISP provider. So that being said, what is now a private IP address? Now, the private IP address of a system is the IP address that is used to communicate within the same network. So using the private IP data, information can be sent or received within the same network. So right here, you are not connecting to the internet, you're not moving outside. So what is this? Now, immediately you're in a local area network, right? Now, you would be definitely connected to other systems, maybe with the help of a switch or a router or an access point. Now, the communication internally, because of course you are not you're not communicating, or you're not taking data outside of the LAN network to probably maybe the internet. If you're communicating within that network now, or definitely within the same network, you all use a private IP address. But once it gets to the level at which now we have to take communication outside the network, then we now go on, and of course, it uses a public IP address in that situation. But like I said, right now we are, I mean, how this is assigned, obviously, is by different is by different methodology or a different system, but which we'll get to. But let's just understand, the different types of IP addresses at this point. Now, once that is done, you can see, of course, the router basically assigns these types of addresses to the device. So, and of course, we will get to, where we'll start talking about DHCP, which are Dynamic Host Configuration Protocol. Like I said, the kind type of methodologies that, or systems or protocols that assigns these IP addresses. But yeah, you can see right here, it said the router basically assigns these types of addresses to the device, unique private IP addresses, and of course, these addresses are provided to each and every device that is present on the network. Now, what is a static IP address? Now, a static IP address is an IP address that was manually configured for a device instead of one that was assigned by a DHCP. Now, this is becoming interesting. Now, why do I say so? Now, we just looked at, I just explained a concept which was DHCP, which is the Dynamic Host Configuration Protocol, and of course how it assigns IP address. But now we are seeing that in a static IP address, that device IP address was not assigned by a DHCP server. Instead, it was manually configured. Very important to note, the manual configurations is associated with a static IP address. Now, it is called static because it doesn't change, versus the dynamic IP address, which does change, of course. Of course. Now, it's getting more interesting, like I said. Now, static IP addresses are also sometimes referred to as fixed IP addresses or dedicated IP addresses. That's good to note. So now let's come to a dynamic IP addresses. Now, what are dynamic IP addresses? These are addresses that are automatically assigned to each connection or node of a network, like your smartphone, your computer, or a tablet. Now, this is usually accomplished by what is known as a DHCP server. Now, we all have DHCP servers on our mobile phones, on our computer, on our tablet, on our smartphones, and these DHCP servers are what assigns to us IP addresses, private IP addresses, and of course, from a gateway, or from an access point. Of course, we also have DHCP servers that assigns public addresses to our devices that helps us to browse the internet. So these are important to note. Now, what are the roles of ports in networking? Now, if you're just joining us, you're welcome. We're studying understand networking concepts in cybersecurity, or for cybersecurity. Now, these are concepts that you need to be familiar with. We started a series yesterday on breaking into cybersecurity, and I promised that I was going to also begin a series on networking so that we can have the basic knowledge that are essential for us to find cybersecurity easy and interesting. So with this being said, all I would need you to do is just pay rapt attention, just focus on the terms that are being spoken about right here, and if you have any questions, you can always drop them in the comment sections. Now, once again, we're also live on Twitter, we are live on YouTube. Please subscribe to the YouTube channel, follow us on Twitter, CyberVGUni. You can also follow my handle, which is hosting this live stream right now. And please drop your reviews, drop your comments, and let's know how we can definitely improve delivering these types of information to everyone. So yeah, let's get back to business. Now, we have a total of 65,500 535 ports. Now, it's very important for you to note this because you might find these questions in an exams, and they might always want to try to confuse you. But me probably by saying 63,000, 555, you need to be careful about that. We have a total of 65,535 ports. Now, there's something that is known as the state of a port. Now, the state of a port are usually either opened, closed, or filtered. Very important to note this port or this state of the port. What else? We also have well-known ports, and these well-known ports are ports that are from 0 to 1023. Now, it's important to note that right here, it's where we have different ports and their services like FTP, HTTP, things like this. We also have registered ports here. This registered port ranges from 10,000 to 49,151. Now, these are the registered ports. Then finally we have dynamic ports, and these are the ports that ranges from 49,000 to 65,535, which all totals to the available ports that we have, which is a total of 65,535. Very important to note this. Now, why do we say these ports, or how do we define this port? Now, like I said, the well-known ports are from 0 to 1023, and of course, these are what we use in identifying a network service. Remember, I spoke about network service when I said, HTTP, it could be FTP, it could be now. Okay, you can see HTTP here, of course. So, but the point is, the well-known ports are from 0 to 1023. Now, it's very important for us to note that you need to note these for reference purpose and also for study purpose, because you might get into an examination hall and they ask you, they give you a series of port numbers and they tell you what are the services that are hosted on those ports number. You should be able to identify those. Now, residing in the field in the TCP or UDP headers are the port numbers, which are usually associated with packets and of course, the appropriate applications in the server. Now, don't worry about that. We're also going to, once we, are able to round up with this series on networking, we'll start looking at the practical, because it's not just enough for us to, just gain this theoretical knowledge. So we'll be working with tools like Wireshark, where of course we'll have series on how we can be able to also understand and put this networking security aspect into hands-on experiences as well. Now, like I said, the most common well-known port is 80, which is the port that identifies HTTP. I would have just asked a question right now saying, anyone who knows the port for the HTTPS, drop it in the comment section, and of course you get something rewarding for that. So I hope you don't Google or try to find the answer. So now we also have what is known as registered ports. Yeah. Now, and this registered port, like we saw previously, ranges from 1024 to 49,151. Now, these ports are known as network ports, and of course they are designated for use within a certain protocol or a certain application. So they are registered and they are designated already for use. Finally, we have dynamic ports, which ranges from 49152 to 65,535, and these dynamic ports are a range of temporary ports that the operating system assigns to client-side network connections when an application initiates communication with a server. So for communication to occur between your systems and servers online, there are dynamic ports that are assigned, that and of course helps your operating system to initiate these communications. Now, I always tell um, um, when I have the opportunity to lecture like this, I always tell people that, look, think of it like this. Yeah, the port numbers are like the cars, like the vehicles. Now, what A vehicle is just a vehicle if there's no road. It's more or less useless if there's no road. So what is the road right here? The road here is the TCP, or the road right here is the, you know, of course the TCP IP address, or the TCP IP, what is known as Transmission Control Protocol Internet Protocol. That is what is the road. Now, the vehicles are what? The vehicles are the port numbers. Vehicles are the port numbers. Of course, you should understand that the TCP IP spoken about right here also comprises of the IP address. You know, what helps the communication, of course, is the port numbers, because those port numbers are they are the one that like serves the purpose. For instance, you want to browse through to the web using the protocol HTTPS, which is the Hypertext Transfer Protocol on the secure channel. You want a secure port. You want a secure vehicle to that port. Now, what your IP address has to follow through that port. So your IP address has to go through that port, and then of course it's able to access a web server that is hosted, on the internet. So that is how this happens. So the port numbers are like the vehicles, or the port numbers are like the port numbers in this case could be the road, while the IP addresses are actually the vehicles that travel. So the port numbers actually create that channel. So pardon me, the port number creates that channel, and then of course the IP address are what helps their communication. For identification purpose, the client and the server are identified by the IP address, which is the source IP address, and the destination IP address, and then the ports are like that. That road, that path through which they follow. So like I said, we have different port numbers. We have port 20. Uh, so we have port 20. Like I said, it's very important that you note these things. We have port 20, we have port 21, we have port 22, 23, 24, and so on. Now, these different ports have their roles. You can see for port 20 is the file transfer protocol, for 22 is the secure shell, the SSH, it is the secure socket shell for, also you can see for secure login, the telnet, of course, for also for remote connections. You can see the SFTP, which is the simple mail transfer protocol. We have the domain name service, or the domain name server, as you may call it. We also have the dynamic host configuration protocol, which is the 67, 68 port. We have the HTTP, which is the hypertext transfer protocol, and of course you can see the secure channel is the HTTP S441 port 443, and you can see their different types. Now you can see for the FTP, it's a transmission control protocol. The UDP you see here is known as user datagram protocol. Now, it's important to note that in a transmission control protocol, it requires a three-way handshake for this communication to be called successful. But let's not rush into that. We're going to get into that shortly. Let's just take a quick 5 minutes break, and then we get back. Welcome back. Welcome back. Welcome back. Sorry about the little break, you know. So let's just get back to what we are discussing. I want to believe um everyone is, everyone whose life is actually, gaining or finding, of course, this session informative. So let's keep on going. So I just spoke about this port. Now it's very important that you know. I mean, once you see a port number, you should know the services that is being hosted on that port, right? And I've told us we can also see TCP UDP here. Don't worry. We're gonna get deeper into what this these terms means. Like I said, it's the transmission control protocol and user datagram protocol. We are going to get deeper into them. So, but what is important is take note of these port numbers. The application layer port protocol as well. You can see HTTPS, LDAP, SNMP, NTP, and the likes. Very important. Now, OSI versus TCP IP model. A lot of persons usually have, you know, they usually, say, okay, this OSI model is so. Now let's make this very simple for us. What is an OSI model? How does it work? What is the TCP IP model? How does it work? And then we'll look at the OSI versus the TCP IP model. Now, the OSI stands for the Open Systems Interconnection. The OSI stands for the Open System Interconnection, and of course, it's a reference model that specifies the standards for communications protocols and also the functionalities of each layer. Now, think about this. How do you think communication was done on on like primitive systems? Before the rise of this OSI model, we had instances whereby for for a for a let's say for an example right now, if you have an ASAP system and you're trying to communicate with an HP system, there would have been glitches, there would have been issues in communication, except if you are having an ASA system and another ASA system, and then you can communicate with each other perfectly. But now think of the OSI model as that model that came in and then made the communication of ASA with HP, with Mac, with, every other type of systems, made the connection very easier, make the connections seamless. Now, like I said, the OSI has been developed by the International Organization for Standardization, and it has a 7-layer architecture. Now, this is the model that helps different, today we see the instances where we have, different access points or different routers, and of course, different systems. And how are we able to intercommunicate, or how are we able to communicate, or establish interconnectivity between these systems is because of this model. Now, what is the different model and how do they function? We have the application layer, we have the presentation layer, we have the session layer, we have the transport layer, network layer, and then data link layer, physical layer. All these layers have their different roles. Follow me. I want you to, follow me and just get the point. Now, what is the application layer? The application layer is the topmost layer, and this layer provides several ways for manipulating the data, of course, which actually enables the type of users to access each network for ease, or with ease rather. Now, the application layer provides protocols for easy information exchange and data presentation. I mean, for instance, how are you able to we have or we host web pages, right? And these web pages contains, of course, different types of informations. There are files, there are sometimes media, sometimes of course, medias, web pages, pictures, these types of things. Now, the application layer is the layer that helps or gives us that interface, to be able to directly interact with such types of web application services. Without this application layer, you might probably not be able to, view certain pages correctly. For instance, when you just write an HTML, an hypertext markup language, and then you host an HTML. Now, with, with you putting the pictures, with you writing the back end, and then of course, maybe you have pictures are associated, colors, those types of things. What helps you to, or what gives you that visualization is because of course, the application layer functionality. Now, for some reasons, you know we have this layer in the help of what is known as file management. You can see some examples are Telnet for file management, DNS for domain name translation, DHCP for IP address provision, FTP for file transfer, SMTP for email transfer, and of course HTTP for web browsing. Now, these are what comprises, or these are the functionalities that are embedded in an application layer. So just understand this, as that layer that helps, basically, for or provides, access, easy access directly for application processes. Now, what is the presentation layer? Now, the presentation layer is the sixth layer in the open system interconnection, which is the OSI model, and this layer is also known as a translation layer. Now, this layer serves as data translator for the network, right? The data which this layer receives from the application layer is extracted and manipulated here as per the required format to transmit over the network. So now you can now see how these layers both work hand in hand. Now, the main responsibility of the presentation layer is actually to provide or to define the data format and the encryption. And of course, it's also known as a syntax layer because it is responsible for maintaining, proper syntax of the data which it receives or it transmits to other layers. Now, let's look at some actual protocols, and their functions. We have, for instance, the secure socket layer, which is a protocol that encrypts data that are transferred between a web server and a browser, and of course this ensures privacy and protections from attacks. We also have what is known as the Apple filing protocol, which is the acronym is AFP, and of course, it's a network file control protocol for the Mac OS. We also have the lightweight presentation protocol LPP, which provides ISO, or the presentation service of course ISO, on top of TCP/IP based protocol stacks. Now, all these are some of the network protocols of on that of course functions with presentation layer, and you can see each of them and their functions. Now, what is the session layer? Now, the session layer is the fifth layer in the OSI model, and what this does is this allows users to establish different active communications. Now, for instance, think about this simply as when you open your web browser, you're able to log into different tabs. You're able to use different tabs simultaneously. Now, how is this done? Ever thought of how this happens? This is with the help of what is known as the session layer. So with the session layer, you're able to establish different, you're able to establish, you're able to maintain, you're able to synchronize, and even terminate sessions, between end user applications. That is basically, what a session layer is. Now, we also have the transport layer. What is the transport layer? Now, essentially, the transport layer is the fourth layer in the OSI model, and it plays a critical role in ensuring that there is steady and efficient transportation of data amongst end systems. Now, what this does is, as the name implies, it's a transport layer. For instance, the transmission control protocol, which provides reliable and of course error checked data delivery communication that is being transmitted, carrying data properly, in the order at which it was sent, to its destination. That is simply what this transport layer is. Like we spoke about the TCP, UDP, we spoke about the ports, right? So all these are embedded. All these are, are what, of course, the transport layer facilitates. Now, the network layer on its own is the fifth layer from the top, and of course, is the third layer from the bottom. Why is it important? It's because it plays a key role in data transmission. Now, for instance, this layer handles what is known as routing, which means choosing the best path to transmit data from a source to a destination, not just the transmission of the packets. And of course, there are several important protocols that works in this layer. For instance, the internet protocol itself works in the network layer. We have the IPsec, which is a secured, form of the internet protocol. We have the INCP, which, of course, one way or the other, we probably must have heard of things like the ICMP packets, rather. We also have the IGMP. Now, all these are found on the network layer. We have the data link layer. Now, this data link layer is, for instance, think about this as the layer that plays a major role in ensuring, the free flow of transmission of information. For instance, we have the dynamic link library, which is also responsible for encoding, decoding, and organizing the outgoing and incoming data. So this is considered the most complex layer of the OSI model because it hides all the underlying complexities of the hardware from other above layers. So now there are things to keep in mind, in during this or at this stage of the OSI model. Before we get to the, of course, one of the layers that comes before the data link layer, think of this as, I want to represent the OSI model generally in a visual, or I want you to visualize it. Now you have an RJ45 LAN cable, yeah. That is a physical cable that you can see. But can you see the packet? Can you see what actually it's in the? I mean, once you connect two systems together with a LAN cable, you don't know. You're sending information, but can you actually see those information? Now you can't see those information, but of course there's a link. There's a data link. Yeah. Now this is the link, or this is that layer that helps that communication. Now, which brings me to what I was just saying to us, the physical layer. Now, the physical layer is the bottommost layer of the OSI model, and what it does is it consists of various network components such as power plugs, connectors, receivers, cable types, different types of different types of connectors or receivers that helps, or that aids communications, of course, of raw data streams over a physical medium. You can see the Ethernet, you can see Bluetooth, you can see, of course, the serial bus as well. So all these are at the physical layer. Now I hope now you have been able to understand. So if we want to look at it, practically with the little explanation that I gave, now let's take a look at this. So at this layer, we would find, of course, the RJ45, right? Now we can't see what is being transmitted on the RJ45, but of course we know data is being sent, which is handled in this layer. Now, by the time we get to this layer, what is happening? Now we are taking data across the internet, and they need a network layer. They need to, of course, communicate through which medium. It could be a router, it could be an access point, of course. Now, while on the internet, we need to be able to, transport, data from one place to another. What comes in handy there is our transport layer, of course, providing TCP or UDP access, or those types of communication that helps us to, communicate. Then session layer helping us to manage those sessions that we have established. The presentation layer, of course, also giving us, meaningful information of what we are doing and finally the application layer that keeps everything, together in one piece for us. So this is what comprises of in the OSI model. Now we can see there's another beautiful, very interesting graphical illustration right here for us. You can see the physical layer, the data link layer, network layer, the transport layer, the session layer, the presentation layer, and finally the application layer. We can see how each of these layers helps. Now we can see as they all travel up, we can see what is happening to them. You know, each header, each headers are being removed, and you can see the data in themselves, being, I mean, at the topmost, and of course the receiver being the application layer. So I hope up to this point we're able to understand things that are happening. Now, this is basically what I just explained to us. At the physical layer, we have the hubs, repeaters, modems. At the data link layer, we have the switches. The network layer, I told you, we have the router. For the transport layer, we have different devices. For instance, we have the gate, the firewall. The session layer, of course, we have the gateways. Presentation layers, like I said, we have the JPEG, MPEG, application layer. We have the SMTP. Pardon me, I think there was a there was a mix up. So the presentation layer actually, of course, helps the data from the application layer that is extracted, and of course puts it in a required format that makes it presentable. I mean, and visualized to us. And of course, finally, we have the application layer. So that brings us to what is known as the TCP/IP model. I remember I spoke about this, which is the Transmission Control Protocol Internet Protocol model. Now, the OSI model we just looked at is just a reference and a logical model. It was actually designed to describe the functions of the communication system, by dividing the communication procedure into smaller and simpler components. Now, very important, when we talk about this TCP/IP model, this is a model, or this is a yeah, it's a more it's like the OSI model, but of course it comes in, instead of 7 layers, it comes in 4 layers. Now, unlike the OSI model, and of course we are going to study how, of course, we relate, or we have this we have this you know TCP/IP model designed on how it also describes the functions of communications that happen, you know of course, on the internet or on networks. So now, what is the difference between TCP and IP? Now, the TCP and IP are different protocols of computer networks. The basic difference between TCP and IP is in the transmission of data. So, in simple words, IP finds the destination of the mail, and TCP has the work to send and receive the mail. That is why I told you there has to be a form of what is known as three-way handshake, for a communication to be considered as complete when it comes to the TCP IP, and of course the UDP as well. But right now we are not actually even we're not discussing, you know, um, TCP UDP right now. We just want to understand what TCP IP means. So now, what are the layers of the TCP IP model? We have the application layer, we have the transport layer, we have the network access layer, as opposed to the OSM model layer, where we have about 7 layers from the physical up onto the application layer. Now, what does each layer do? Now, let's look at this from the very bottom. The network layer comprises of the physical and the data link, and of course it has the work of transmitting the data amongst two devices within the same network. It's as simple as that. What does the internet layer does? What does it do? The internet layer is similar to the network layer of the OSI model, and it helps the movement of data packets from the destination to the source, and of course from the source to the destination as well. We also have the transport layer. Now, in the transport layer, this is similar to the, of course, transport layer as well of in the OSI model, and its purpose is for the reliability and error-free message delivery. And then finally, we have the application layer, which is the topmost layer of this TCP/IP model, and it forms the combination of the application, presentation, and session layer of the OSI model, and of course, it works in providing access to the networks. So this is now you can see the OSI versus the TCP IP, which is, of course, having the application layer, presentation layer, all as a single application layer, transport layer as a transport layer here, the network layer as a network layer here, and the data link and physical layer here as the network access layer. Now, it's very important for us to, understand this because, of course, we might be trying to prepare for examinations and questions like this might be asked. So, and the essence of this is to give us that knowledge, is to help us to understand these concepts. Now, of course, if you're just joining us, you're welcome. This is understand networking concepts for cybersecurity, which is an a very delicate path, an important path towards your journey in cybersecurity, understanding networking, because this is, of course, networking comprises of almost 80%, of what you have to know in cybersecurity. I mean, if you're trying to, protect IT infrastructures, you must know how they communicate, and to know how they communicate, you must, of course, understand networking. Now we can see the TCP/IP old and new versus the OSI model. Now we had the 5 layer for the TCP, and what was not included there was, of course, the data link, which right now for the TCP/IP new layer we have a straight transport layer, internet layer, and then the link. So we don't have the data link, that is, that was on the 5 layer TCP/IP. So right now we have the 4 layer TCP/IP, straight up application layer, transport layer, internet layer, and then the link layer as well. So what are the protocols in networking? So what is network protocols? What are the types of protocols? How does TCP work? And then what is the TCP three-way handshake? This is what I spoke to us earlier. And then the TCP versus the UDP. What does these things mean? Now, a network protocol is simply a mechanism or a set of procedures that helps devices to communicate back and forth. Simple put. So what the network protocol does is it has, different mechanisms. It has sets of procedures. Now, these sets of procedures must be followed for the establishment of a communication which is back and forth across the internet to be effective. Now, on this network protocol, we have sets of rules. We have how data is transmitted. We have device communication. Look, it's just like anything in life. There are a set of rules. If you wake up in the morning and you need to get into your car, there are things you need to do. You need to wake up, bathe, you need to brush, freshen up, wear your clothes, and then of course walk into your car, and then you drive. And for the car to move, there needs to be fuel. You need to start the engine. These are just set of rules. These are protocols that you do for every day for you to achieve or for you to get to your destination, maybe your office or wherever you're going to. The same thing on the internet. There are things, there are protocols that needs to be followed. There are set of rules on, of course, how data is transmitted, of course, net device communications for a network to be able to gain establishment between different devices and their communication back and forth. So let's look at that. We have different types of protocols. We've looked at the TCP/IP, we've looked at the OSI model. Now let's look at their protocols in depthly. This is very interesting. Now, when we talk about the physical layer, what are the protocols? What helps us to establish, of course, communication? Bluetooth. You can connect to your internet through the use of Bluetooth. Yeah, you can use an Ethernet cable. You can use a DSL. which is a dial-up link. There's the ISDN, and then we have the 802.11, of course, the Wi-Fi. These are the protocols. You want to browse the internet, choose these protocols, and you will get access to the internet. It's as simple as that. Now, what are the data link layer? The data link layer, of course, this layer that helps us to, of course, understand what messages are being sent. For instance, we have the address resolution protocol here, right here, and of course, this is the protocol that, of course, resolute the IP addresses. So, if, for instance, you're trying to browse a certain website, of course, what your system understands is zeros and ones. So, at this layer, these protocols, the PPP, the STP, the frame relay, are what is helping your system to understand, okay, this is the source, this is the destination, and the likes. Network layer, we have the ICMP, we have the IPsec, we have the IPv4, the IPv6. Now, of course, at this layer, you are now communicating to the internet, and you want to be able to browse the internet. Yeah, how do you do this? You need the transport layer. Now, the transport layer, like the TCP UDP, is what gives you that, that is what establishes that connection. Like I said, for TCP, you need a three-way handshake to be considered as, okay, connection established. For the UDP, you don't, because it's just it's a connectionless oriented, connection. You know, Now that brings us to the session layer, and of course we have things like the net BIOS, the PAP, the SCP, SQL, ZIM. These are what helps us establishing different, maintaining these different sessions and the likes. We have the presentation layer, of course, the JPEG, the MIDI, the MPEG, the PICT, and this, forms of protocols. Finally, application layers, where we have the FTP, we have the SSH, SMTP, we have the Telnet, which helps us, in speaking with these, applications, even, sometimes not having to have physical touch with them, but able to remotely access these applications, and these protocols are what helps us to achieve that. Now, how does TCP works? Now, it's very important to know that in TCP we have what is known as flags, and there is a total of 6 flags. We have the urgent flag, we have the finish flag, we have the reset flag, we have the push flag, and we also have the acknowledgement flag. Finally, synchronize flag. Now, what does each of these flag means? We're going to have a deep look into them, right now. Now, the urge flag, which is the urgent, focuses on the data that are contained in the packet and how they should be processed, which it's saying, of course, as the name implies, urgently. So once this flag is added to a particular packet, what this tells the destination or the server is, A, deal with this packet immediately. Give me information that I'm requesting immediately. That is how, of course, the computer understands, okay, this is an urgent communication and it needs to be processed immediately. The finish flag, of course, talks about, fine, we are done communicating, thank you for your session, finish, say fini, and we both go our separate ways. The reset flags talks about resetting the connection. Maybe there was an issue, okay, and then the transmission wasn't as effective as it should be, it got terminated. Now we reset the connection. Now once a packet carries this flag, it knows, okay, we are resetting this certain connection. The push simply means, sending all buffer data immediately. So saying, okay, now I have this data and I have them buffered, kindly push them out, and of course let me know that they are already, out there immediately. Also, we have the acknowledgement of the receipt of a packet. So once a data has been sent and the server received those data, and of course, want to acknowledge, an ACK flag is sent on that packet saying, thank you, I received this data, I received this packet. And of course, the initiation of a connection between two hosts is identified by the SYN flag. Now, when we talk about the three-way handshake, which we're going to see shortly, you will see it comprises of the SYN arc, and of course the arc. Let's look at that. Okay, that is where we are right now. So here the three three-way handshake. Very interesting topic. Now look at, here is the client, here is the server. Now for a communication to occur, you can see it's going to be occurring on port 21. Now what happens? What does the client do at first? The client knocks. He said, hey, this is a SYN flag and I'm trying to communicate on port 21. Is this port open? Now what happens at the server end? The server receives this SYN flag and then sends this back, the SYN flag, with an acknowledgement flag saying, yes, I am port 21, and of course I am open. Now what does the client do here? Now at this point the client says, oh fine, I received your SYN and I received your acknowledgement. Okay, then thank you for this. Now let's establish a connection. Now you can see what has happened here is, of course, they established a session, they established a connection to enable effective communication to proceed within this network. So it's always very important to note that in a TCP connection oriented, in a connected oriented state of connection for TCP, the three-way handshake must be complete. The three-way handshake must be complete as against the UDP, which doesn't require the three-way handshake, because why? It's a connectionless oriented protocol. But let's go further. Now this is a TCP termination session as well. You can see the client and the server also again right here saying, hey, I'm done with the data transfer. Now can we close? Sending it with a finish flag. Now take note of this. Now it's saying, okay, fine, I read this now, and I'm acknowledging. Remember when it was about to establish a connection, what it sent was a SYN, because it's establishing, but here it's terminating. So it's sending a finish flag. Now it's saying, okay, fine, and I'm acknowledging this, and then it's saying, okay, fine, I've received your termination request. Let's cancel or let's terminate our request. Now and then this is the client, of course, is replying back saying, okay, thanks, and then of course termination is, or the session is closed. So now why as security analysts or as security professionals, why do we need to focus on this? Why are we teaching this, or why are we learning all this? Now we want to understand how communications has occurred on system. You might be presented with log files, and you are being required to inspect those log files to identify how communication occurred on a certain session. Now it's your duty to be able to understand, of course, the client, the server, how they established the connections, how long it took, and of course when the session was terminated, the duration between the establishment and the termination. That is why we are studying this. These are things that are important for cybersecurity professionals to note. You need to understand how networks communicate. Now, what is a UDP communication? Like I said, UDP stands for User Datagram Protocol, and it's a transport layer protocol that is part of the IP protocol suite. Now, unlike TCP, it is unreliable and it is connectionless. I've said this before. It is unreliable and it is connectionless. So there is absolutely no need to establish a connection prior to data transfer, and the UDP helps to establish low latency and loss tolerating connections to be established over the network. That is simply what a UDP connection is. Now you can see, for instance, this is a TCP where we see the SYN, we see the SYN ARC, and then we also see the ARC. For the UDP, it's just requests, response, 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 and response. So there is no form of establishment, there's no form of acknowledgement, between them, or on saying, hey, okay, our session is established. Then for instance, here a session is established, and then a session can be terminated. But right here, no session was established. Everything is just request, send, 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 send. So that is what differentiates between the TCP and the UDP. Now let's look at other differences. The TCP is a connection-oriented protocol. I've made mention of this. The, and of course, it's comparatively slower than UDP. Yes, because of course it uses handshakes and it establishes connections. And the TCP is used by HTTP, HTTPS, and these types of services. Now the UDP is the user datagram protocol, which is of course is the datagram oriented protocol because of course it is faster, simpler, and more efficient than UDP. It is connectionless protocol, that is there's no handshake, and finally the UDP is used by these types of services. So let's talk about domain names and zone files. Now, what are domain names? Now, what records are in domain names and what is a zone file? Let's understand this. Now, a domain name is a text that user types into a browser to access a website. But of course, you know, right, that not every computer, I mean, no computer understands a domain name. What the computer understands is what? Zeros and ones. So the use or where domain name comes in very handy for us as IT professionals or as cybersecurity professionals is its mapping of alphanumeric IP address. Now, what this does is when we say okay, google.com for instance, what a domain name does is it tries to associate this google.com to an IP address and then remembers, okay, this is the IP address of google.com and this is where this is asking me to go to, and then it tells the server, hey, I'm trying to access google.com and this is the IP address of this google.com. Of course, the IP address definitely will be stored, in the cache, and of course other sessions that might have been established. But yeah, it tells it, I'm trying to access this, but of course the computer doesn't understand what google.com is. But it has helped, the domain name service has helped us to translate that name into an IP address, and then helps us to fish out the web page associated with that IP address. Now, what is a subdomain? A subdomain is simply an extension or an add-on to your business domain name. So subdomains are used to organize different functional parts of the website. So for instance, you have this as the domain name, and then having this as a sub domain name, which is the blog slash google.com, which could be also things like sign in slash google.com. This could be sign out, this could be account slash google.com, whatever it is. So that is what a subdomain is. Now you can see what a subdomain is. Let's look at it here. You can see the protocol. Of course, we've talked about these. You can see the subdomain, you can see the main domain, and then you can see the web page right here. So this is what a subdomain looks like. Now, I just spoke about the domain name system. Okay, of course, now you can see right here the domain name service serves as the phone book of the internet by translating domain names to IP address. So this is what I just spoke about, allowing web browsers to access internet resources. So on the domain name system, like I said, it's like an address book, so it translates the domains to IP address, and then of course it stores all the data in form of records in the zone file. So this, I know so many persons might look at what is happening. Look, this is what is important for us to be able to. I mean, for especially for cybersecurity enthusiasts, you need to understand. You know, you need to understand uh, the networking, because networking is definitely, you know, like I've said this countless times, it's an important aspect of cybersecurity. It covers almost 80%. So you really want to understand what networking is. So now we have different records and their use. So for instance, we have record A, which is the IP of a domain name, and then we have different things like TXT, which is any text by the admin, do this properly, we also have the NS, which is, simply the name of the server. We have the SOA, which gives information about the domain. We have the SRV, which specifies ports for specific services. And then we also have the PTR, which of course provides domain name in reverse loop. So basically what you need to understand here is the records and then what they are used for, and then having this understanding, gives you, you know, a clear perception of what, the types of records that will be stored, on a domain or on a DNS. So you can see MXA, which of course directs mail to email server. So what is a zone file? We just spoke about how these IP addresses are stored, or I mean, like a phone book, and how they are stored in the zone file. But what exactly is a zone file? So a zone file is simply a plain text that stores all the records for every domain within a DNS server zone, starting with the start of authority, which is an SOA record that contains essential information, for such a zone, and of course the administrator's contact details. This updates every 4 hours, and in this record we have, of course, the records of domain, we have the IP addresses mapping, and then we have the name server zone for each of those IP addresses, which maps their servers, of course. So what is a request versus a response? And what types of requests and what types of response methods do we have? Let's look at this, including the HTTP status code. So when we talk about an HTML request, I spoke about this earlier. I said, of course, we know an HTML is an hypertext markup language. Now, how is this associated with, the browsers? Now, the HTTP request is the call that the client or the browser makes to the web server, right? And of course, it contains a packet asking, okay, I want to visit this page, I want to visit google.com. Now, included in that packet will be a get, post, headers and body. Now, we are, like I said, we are going to be looking at packets very soon, where we inspect packet, but let's understand these terms, let's understand these concepts, because these are what helps us, as cybersecurity, or professionals, or analysts, to ground and master this concept. So, oh great, so we have something very similar to a packet here, and I want us to get some things. Now you can see right here what is happening now. This is the request line. This is the request line where we just read saying get certain information. Now here we can see it's saying get this test file, which is an HTML, and of course with the protocol embedded with it. Now from the host test 0 test101.com, we can also see the accept header. You can see what language, you can see how it's encoded, definitely the user agent, which is the Mozilla Firefox, and then the content length of this packet, or the content length of this data being sent. Now what is this trying to tell us? Firstly, we saw the request line, then we saw the request headers, and of course the message also embedded in it, and then we have a blank line which separates this header and the body. Now what is important to note here, of course, we can see the supported media, of course, with this the supported encoding structure of that, and then finally we saw the user agent. Now this is just an example of what happens when a request is being sent over on the internet network. Now what is a response, or what is the HTML response? Now that we'll focus on the main components of the HTTP request, it is time for us to examine the HTTP response, which is the response that the server sends to the client following each request. Now, each packet providing permissions to access websites and context. Of course, we include the get, post, headers, bodies, and of course the complete program of that page. So that is definitely, we've seen the request. Now let's look at what a response would look like. Now you can see the response header. Now definitely we saw the protocol at which this traveled. Now we've seen additional information like the date. We can see the server. We can see the last modification of this, and then we can see different tags. We can see the e tags. We can see the content length. We can see it's even giving us information on the state of the connection, and then we can see the content type. Of course, it was an HTML that was requested, so we can see as well the content type. And then, oh, sorry, forgive my, yeah, and we can see this as well. So what informations are we getting from here? The status line, of course, the response headers. What's happening to my, yeah, and then we can definitely this same blank line, and then finally the response message body. So all these are what comes in an HTML response. So we have different types of request methods. We have the get, of course the headers, we have the post, we have the put, we have the delete, we have the options, we have the trace, we have the connect. Now what does this ring a bell on? Now this just rings a bell on the flags that are contained in a TCP IP connection, which are the seen, acknowledgement, finish, and the likes. But of course, we are looking at it in the concept of an HTML request. Our data pages have been requested. Now we can see the get simply is talking about transferring the data across the unified resource locator, and of course making it easily visible, and in this case not secure, of course, because depending on the type of if this had to be on a protocol like the HTTPS, definitely we will be talking about a secure connection. But right now, consider this as a not secure, um, you know, request method. Of course, we have the head, which is the same as the get, but transfer the status line and the header section only. We also have the post, which sends user information and files in the body, of course, to what now? To serve the using HTML forms. Yeah. Now we also have the put, we have delete options. All these are the different types of request methods. Put is replacing all current representation of the target resource with the uploaded content. Delete is removing all the current representations of the target source given by a URL. Options is describing the communication options for a target resource. The trace is performing a message loopback test along the path for the target resource, and then the connect finally is establishing a tunnel to the server that is identified by a given unified resource locator. So these are the different types of request methods. Now, what's an HTTP status code? Now, what this status code means is it's simply what gives a search engine the optimization of, you know, indexing the certain or the performance of a website. Now, what does this mean? For instance, when you get things like the one double X information, one XX information, what it means is the request was received and the process is continuing. When you get this type of code, it tells you that the action was successfully received, understood, and is accepted. And when you get this type of code, what it tells you is that there is a redirection. When you also get this type of code, it shows to you that there's a client error. When you get this type of code, and then it tells you that there's a server error. So all these codes, it's essential for us to understand, of course, this is our different statuses, or different, these are different status codes. So these are the most different types of code. I know we are very, very familiar with 404, of course, which we see, time to time. But there are also codes like the 200, which are okay. Some of these we don't see because, of course, when these things happen behind the scenes, you know, uh, like I said, this happens behind the scenes. Yeah. So, but we are very familiar with 404 not found. Um, sometimes we sometimes we run into bad gateway 502, and of course 504 timeout. Very little, or not, you run into too many requests for tonight, code. But of course, these are some important code that you need to note. So what are network devices? Now, network devices are also known as networking hardwares, physical devices, and of course they allow, you know, hardware or computer network to communicate and interact with one another. For example, the repeaters, switches, routers, gateways, these are all considered as network devices. You can see a repeater right here, and you can see its different components. So what it does is it regenerates and amplifies the network signals to extend the transmission length over the same network. So it's what it's doing is, a form of boosting, the network, and of course, it's ensuring also that the signal's original strength remains intact. We also have an hub, which usually is not as smart as a switch, but what it does is it's a kind of multi-port repeater that connects multiple wires from different branches, and of course, it follows this star topology, concept. Now, however, ops cannot filter data, resulting in data packet being sent to all connected devices and creating a single collision domain. Ops also lack intelligence to find the best path for data packet. So when it comes to forms of multi broadcast, things like that, the ops are not usually as smart as the switches. We also have what is known as a bridge, which operates at the data link layer. And of course, a bridge is simply a repeater with add-on functionality of filtering context by reading the MAC addresses of the source and the destination for each of those packets. So we have a switch. A switch is a more smarter device than the hub. So what the switch does, of course, is to you know it acts as a multi-port bridge for with a buffer, and of course with an efficient design, and it performs error checking before forwarding data. So that's the advancement on a switch. Now it makes selective forwarding on only good packets, and of course to the correct ports. Now, the switch devices also devise a host collision domain but does not change the broadcast domain. So it also helps in, of course, um, averting collision.
Hello. Hi, how are you? Bro, please give me.
Now we also have a
Second times.
router, and we all,
20.
I'm very sure we are all familiar and
20.
understand what
Please,
a
if you can
router
speak and
device
again.
is. Now, a router is
Okay.
simply a network layer device that directs packets based on their IP addresses, and it connects LANs and WANs, and it also has a routing table that updates dynamically and makes decision on routing packets as well. So we're looking at networking devices, and of course how they are being used. Now, of course, we also have a gateway which serves as a passage, in connecting two networks that may work differently. So what this does is it takes data from one system, it interprets it, and then it transfers it to another system. Now it can also operate at any network layer, and is also known as a protocol converter. So gateways are more complex than switches or routers. Then we have a router. Now a router is just simply a bridging router, and it converts, or it combines rather, the features of both a bridge and a router together. Finally, we have a modem, and of course, the modem, what it does is to connect your local area network to a wide area of network, such as the internet, for instance. These types of device, the NIC, we usually find them in our embedded in our systems, in our laptops, and of course they are like an interface card that helps us to connect our computer to the internet. So we have different types of NICs actually. We have the internal network card and we have the external network card. So most of what we do, or most of what we use, are the internal network cards. We also have the external network cards that helps us sometimes as ethical hackers to be able to also do things like penetration testing, wireless hijacking and things like that. Okay, so that leaves us with data transmission mode. Now, what is data transmission mode? A data transmission mode is simply the mode that describes how two devices in a network communicate or exchange data. Now, it specific or it specifies the direction in which the signal should travel over the media, and of course the types or number of signals that can traverse through the media at any given time. So when you talk about data transmission, what we're essentially saying is, okay, how are data being transmitted from a point A to point B, from my system to your system? How is the data being transmitted? And we have different types of transmission. We have the simplex, we have the half duplex, and then we have finally the full duplex. We'll look at that shortly. Now let's look at what the simplex means. Now the simplex simply is, an unidirectional state of communication. This allows the signals to travel in only one direction. Now from the server to the receiver. So if you look at this, for instance, what do you think would be, excuse me, what do you think would be something very similar? What comes to mind? Of course, the UDP, because UDP just goes in one way, yeah. And we can also say that the sender device use the entire communication channel. So, for instance, when you use your remote, that's a type of simplex communication. So, I mean, for instance, you can see, TV remotes, garage door openers, smart speakers. All these are types of, simplex, because they only travel one way. When does your television does not communicate with your remote? It's only your remote that communicates with your television. So we have the half duplex. Now, what the half duplex does is it allows signals now to travel in both directions, but only in one direction at a time. So, for instance, when you hold a walkie-talkie and you're talking, when you say hello, the other person has to wait for you to, of course, respond to saying Roger, and then he gives in his message, and then those types of communication. But of course, the communication has to be one at a time, even though in this type of half duplex, signals can travel in both directions. Now, in the full duplex, I mean, you already understand what this would mean. It's allowing communication, simultaneously. So sending and receiving of data simultaneously as it's going in, it's coming in. And of course, this enables the device to perform both tasks at the same time. A two-lane highway is a real-world example of a full duplex communication. What are Ethernet cables? Now, Ethernet cables, like I told us, just like you have the RJ45, right now we are having the Cat 5e, Cat 6. All these are types of Ethernet cables. They are physical cables that helps us, to communicate, and of course helps us in ensuring that we can physically connect our PCs, our routers, our switches within a local area network. So these are different types of cables that we have. We have the twisted pair cable, we have the shielded twisted pair cable, we have the unshielded twisted pair cable, we have the straight through, we have the crossover, the rollover, the coaxial, the fire optical cable. So this is an example of the twisted pair cable. Someone might ask, why are we studying these things? Well, I'll just tell you, welcome to you know um, this session on understanding networking. cybersecurity, and I can assure you that with the study of these the study of this concept, right now you're beginning to understand, okay, this is how communication occurs on the internet, and of course you're getting prepared for the cybersecurity journey holistically. Now this is an example of the twisted pair cable. You can see it's a type of guided media invented by Alexander Graham Bell. Now these are simply two copper conductors being twisted together with insulation, and of course helping helping what is known as the signal quality to travel across two devices. So we have different types of these twisted pair cables. We have the unshielded twisted pair, and it of course has its disadvantages and its advantages. um, yeah, for the purpose of this live stream, we're not really going to deep dive into the twisted pair cables. Of course, what we want to really understand more are the technicalities, but of course these are equally important as well. You know what I'm trying to say is, of course, I mean, you can as well have a screenshot and then take note of these things and understand what types of cables are being used. So we have also the unshielded twisted pair, we have the shielded twisted pair, oh sorry, and then we have the shielded twisted pair. Of course, you can see they also have the disadvantages and the advantages. Finally, we have the straight through cable. Here we use this cable to connect pieces to switch, pieces to orbs. I believe you must have seen these types before. So we have straight through. We also have crossover, but this uses the RJ45 Ethernet cable. And of course, you can see for the straight through, when we are connecting two devices that are like the same devices. For instance, a PC to PC, we use this step. A straight through cable is used to connect the following device, a PC to switch. So when we're connecting to two devices that are of course not the same, we use a straight through rather. Very important. And then when we use a crossover, of course we are connecting devices that are in the same category. So a straight through cable we'll use when we connect a PC to a switch, a PC to a hub, a router to a switch, or a switch to a server, or an hub to a server. So when we're using the crossover cable, you can see we use it with the RJ45. We're connecting two the same devices, two computers, two hubs, or a hub to a switch, or a cable to a modem, or two router interfaces. So this is just what a graphical representation of a straight cable is, and then the crossover cable as well. So we also have the rollover cable. You can see this has um, this has an RJ45 point here, and of course this is the I think this looks like a VGA type of connection, if I'm not mistaken. So we have these coaxial cables, and of course, I believe we're all familiar with these. You've probably seen this one time, connecting your cables, you know, your maybe your depending on type of television networks that you use, you must have seen this cable being used for connectivity. We also have the fiber optics, which are now used, like I said, in Cat 5e, Cat 6 types of, and of course they use more of uh, wavelength division multiplexer that supports two nodes, and of course we need they are named um, unidirectional and bidirectional. So we have what is known as network topology. Now, what is network topology? In computer networks, there are different ways through which different components are connected to one another. So network topology is the way that defines the structure and how these components are connected with each other. So the types of network topology we have the bus topology. Now you can see simple. The bus topology is just, it's a type of network in which every computer and network device is connected to a single cable, and it is bidirectional. Now, it is a multi-point connection and non-robust topology because if the backbone fails, the topology crashes. And of course, in bus topology, we have various MAC, which are media access control protocols that are being followed by a LAN internet connection. So right now we can see how a bus topology looks like. For instance, this is the, you can see the first system right here that comes in from the network right here. Now you can see if any of these connections to these systems fails, now that has broken the connection in, or I mean for instance, if I'm not able to communicate, if the system is not able to communicate to this network anymore, that renders this connection, you know, it renders this connection failed, because in a bus topology, the data flows, you know, it flows bi-directionally. So the ring topology connects devices in the ring with two neighboring devices. So just as you can see, it uses what is known as repeaters to prevent data loss when transmitting data to the last node in a large network. So data flows unidirectionally, but dual ring topology can be used to make it bi-directional. So you can see the flow of message. It starts from here, it goes to here, starts, it goes, it starts, and then which makes it a ring form of topology. So if the connection here is terminated, this still communicates with this communicates with this is still communicating with this. You understand? And of course, one way or the other, we can still have communication link back here. I mean, as opposed to here, like we said, this is the originator. So once we lose connection with this, so that means that right here, this is the master connection. So right here we've lost connection, right here we've lost connection, right here we've lost connection, right here we've lost connection with the master connection. But right here, let's assume this is the master connection. Once we lose connection here, everyone is still connected to the master connector. Yeah, even if we lose the connection right here, and if we lose the connection right here, we are still connected in the network. So what's the star topology? So basically, star topology, connects all device to a central through a cable, and you can see, the how the graphical illustration looks, even like a star. That's why we refer to it as a star, connection. So every of these devices are connected to a central orb. Of course, this orb is not as smart as a switch, but we use RJ45 cables to connect them, and of course the CSMA as well. Then we have the tree topology. In this topology, we have the different, variation of star topology involved, which makes it, a tree topology. Now we have protocols like DHCP and the standard automatic configuration being used here. Then we have a mesh. Now the mesh is simply every device being connected to another device via a particular type of channel. Now in the mesh topology, the protocol used are AHCP, which is the ad hoc configuration protocol, and then dynamic host configuration protocol. So you can see how everyone is connected to here, is connected. You can see the connection here. 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 You can see this connection here. You can see the connection here. They are all connected, and that's what makes it a mesh topology. We have the hybrid topology, which is typically a combination of all the various types of topology that we've studied. That is what we call the hybrid topology. So you can see, just like we've made mention of, point to point, the bus, the ring, the star, the tree, the mesh, and then finally the hybrid. Then this is an example of the local area network, wide area network, metropolitan. You also have the campus area network. I mean, your campus, you may probably have the campus area network. And then finally, we also have the home area network. So yeah, we are almost we're almost done. So let's just take a 5 minutes, 10 minutes break, and then we'll come back to round up the session. Okay, so let's continue so that we can round up and conclude this session. Discuss technology. So we're going to discuss the transmission technology right now. So what is the transmission technology? So the transmission technology involves sending and propagating analog or digital information signals. It also includes the physical layer protocol tasks such as modulation, demodulation, and line coding, as well as higher level of what protocol tasks such as digitizing analog signals and data compression. So basically, like I said, the transmission, technology is focusing on those protocol, that are being taxed with things like, demodulation, coding, how, I mean, they are digitizing analog signals, and of course, data being transmitted or broadcasted, from a point-to-point network, or depending on whatever type of network being used in. Now, a broadcast network basically is also known as terrestrial networks. Is a group of electronic media outlets that agree to the air contents from a centralized source. So what we're saying is basically, like when we talk about broadcast news, so we're just saying, there's actually a public routing, or we can say there's a routing of signals, and of course, that's been sent, and of course, by any type of machine, and of course, it's going to be received by every other person on that same network, because it's a broadcast network. So some broadcast systems supports multicasting, which links communication channel shared by all machines in a network. This has its advantages, of course, because in terms of networking, it has no limits. It ensures better utilization of all resources available, of course. But another downside of it is it cannot accommodate huge number of devices, and it does not allow personalization of messages. So there's no confidentiality. There's not confidentiality in the message. Everyone sees the message that's been broadcasted. So this is an example of a broadcast message. You can see, the broadcast coming from, the video server. The destination address is 255. So every bit in this octets are turned on. You can see when we talked about IP addresses, and then this is receiving, everyone is receiving on the network. So when we talk about point-to-point network, we're just talking about, a kind of my system A to my system B, which is a kind of secure and of course private connection, because this establishes between two, or more private, kind of, location or devices, as the case may be, or endpoints, as the case may be. Now, what this does is, of course, it increases productivity, because data is just being transferred. It's not public. It's not transferred, or it's not broadcasted. It's just a point-to-point type of connection. It provides better security. You can see, and of course, the downside is definitely, with this network, we can only collect two sites, because it has to be point to point, and then of course it's very expensive for distance location. So this is an example of point to point. You can see this is point A to point B, and then in broadcast network you can see how we're having this sent, and then everyone receives the broadcast, and then in a type of NBMA network, you can see how different frames are being relayed to different, because see the point-to-point network right here, and of course being established with these frames, coming from, of course, coming from a broadcast from this particular headquarters. So this really is how network architecture looks like. So we talked about a broadcast. So there's also what is known as a unicast. So unicast is simply a type of information that is transferred when there's the participation of a single sender and a single recipient. That is basically what a unicast form of connection is. So we can see here a unicast, which is like a point to point. You can see a unicast is like a point to point. You can see a multicast here. I mean, a multicast is different from a broadcast. This means is we've been selective of who gets the message, but a broadcast gives it to everybody, which is, of course, we looked at the advantages and the disadvantages of such. So here are their futures. We have their futures right here, how they are being transmitted, their network traffic, how is their security level, things like this. We can see for unicast, we spoke about it. This is more secure because the data is sent to a specific recipient. For broadcast, it is less secure because the data is sent to all devices in the network. For multicast, it is moderately, because data is sent to a specific group, just like we looked at. So now, what we are more concerned about, as security professionals, is the security aspect of these, these types of network broadcast. So we also have, I'm not sure what this is on. Okay, let's talk about virtualization very quickly. So virtualization quickly is a concept that helps or separates a service from its physical delivery. So for instance, I believe most of us who are security professionals understand where we have virtualization of VMware, Oracle VBox. All these are, they are just type of technology that helps us to separate our our physical device from a virtualized environment. Now, what virtualization does is it allows the sharing of a physical resource among multiple customers by assigning a logical name to the physical storage, and of course also providing a pointer to that resource on demand. So once, of course, your virtualized environment needs a source, or it needs a particular resource, it requests, or you can assign it, based on demand, and of course, this would come in handy, and you can see it actually plays a fundamental role in form of delivering infrastructure as a service solutions for cloud computing. So basically, this is what a virtualization environment looks like. You can see we have the server hardware on its own. We have the server hardware, then we have an host operating system, then we have the hypervisor, and then on this hypervisor we have different guest OSs. So this might be a type 1 form of virtualization. I don't know if we have other types. Okay, let's okay. So we can see how the virtualization actually works. So for instance, here I have my system, which is maybe HP. On my system I have my Windows, then I have maybe Oracle VBox, and then on the Oracle VBox I have Kali Linux. It has its binary libraries, and then of course the interface where I can view it. So basically this is what a virtualization concept looks like. So we have different forms of virtualization. We have the application virtualization, network virtualization, desktop, storage, server. So virtualization is used for different purposes. On these types of virtualization, we have different interfaces that are being used to operate or control these systems efficiently. We have the command line interface as one, and then pardon me, we have the command line interface as one. What is happening? Then we also have the graphical user interface. So what this basically means is command line interface just allows users to issue basic commands to a computer, while the graphical user interface provides, it provides more, indicators, more graphical icons, for us to be able to interact with our operating system. So for instance, this is an example of a command line interface on which system is this? This looks like a Linux system. This looks like a Linux system because I can see the root at localhost, and yeah, so this is a Linux system. So this is an example of the command line interface. This is an example of the graphical user interface, which is the Windows, as it's glaring. We can see that. So we spoke earlier on IP version 4. So there are different classes to IP addresses actually, and we can see the private IP ranging from 10.0.0 to 10.25 to 55 to 55, which is a class A type of address. We also have the class B type of address, but what is publicly, or what we all use majority of the time, is the class C address. Why? Because of course this allows for approximately 2 million networks by assigning the first 3 bits of the first octet, to of course, either the country, the states, and the ISPs for the use, and then giving the last octet for the devices, as we saw earlier. So we also have the class D. So we have the class A, we have the class B, we have the class C, we have the class D, and we have the class E type of IP addresses as well. So we can see the conversion, and then finally we have what a concept that is known as subnetting. Very important. So subnetting is the process of dividing a larger network into smaller ones, which is why right here you can see things like okay, there's no subnetting concept that was used here. But yes, what subnetting does is it helps us to simplify, divide larger network into smaller ones, even giving us the ability to have more space of taking up IP addresses. So subnetting helps in organizing the network in an efficient way, which helps in expanding the technology for larger firms and companies. You can see that. Then it's also used for specific staffing structures to reduce traffic and maintain order and efficiency. Then subnetting also divides domains of the broker so that traffic is routed efficiently, which helps in improving network performance. So that brings us to the end of networking concept for cybersecurity. I want to thank you all who have joined, everyone who watched up to this point. Thank you for joining me today in this study session for understand networking concept for cybersecurity. See you all in our next live stream. So please follow my Twitter handle, turn on notifications, follow us on YouTube, and then also follow CyberVG University, our platform, for this, which is also our Telegram community. You can find the link on my pinned tweet. Join us and then upskill yourself in cybersecurity. We are committed, dedicated to bringing information that would help you in, having a strong foundation and knowledge in cybersecurity. Thank you.